Right. And thanks to our technical expert, Andrea, for changing over the slides. That's good. Well, thank you very much for inviting me. It's great to be here tonight. And I should start by thanking SOS for inviting me, but also for writing a really good local report, which you should all have a read of, because they've done some great work already in preparing things. So what I want to do is start off with some pretty broad context about the global and Australian situation, then burrow down a bit to look at the context that we in our homes face, and then finish off with a few practical bits and pieces which will lead into Andrea's talk. So that's the theory anyway, so let's see how we go. Just to start with, these are some of the great houses at a development called the Cape in Cape Patterson. And there's lots of information about those houses and their designs and their performance on their website. There's also yourhome.gov.au, which is a really comprehensive national resource for people. And in fact, they have model house plans and things like that for really good buildings too. And for what it's worth, I've given quite a few talks, and some of them are online, and one I did recently at Hillsville might be of interest to you. So it's just a bit of, because we're not going to cover everything tonight. So I will skim pretty quickly over these slides. Now the slides will be made available through SOS, and also we're filming this thing, so presumably that'll appear somewhere too. So you don't have to absorb everything that I skim through tonight. Okay. So let's start at the Australian level, and this is the breakdown of Australia's greenhouse gas emissions, and basically about 80% of Australia's greenhouse emissions are associated with fossil fuel use and production. And you can see electricity is about a third, but coming down quite quickly because people like you are putting rooftop solar and there's lots of wind farms and stuff happening. About a fifth is stationary energy, not electricity, mainly that's gas. And then transport's about a fifth. Now fugitive emissions, some of you might remember a TV series called The Fugitive, which is about someone who escaped. Well, fugitive emissions are gases that have escaped from gas pipes and coal mines and all sorts of things like that and gotten up into the atmosphere to muck up our lives. So that's what fugitive emissions are, mainly methane. Industrial processes, some like cement production and things like that, actually break down chemicals and release carbon dioxide in the chemical reactions and things like that, so that it's not from the burning of the fossil fuels. Then there's agriculture, which is pretty big. Organic wastes, which is the food and everything, and green waste breaking down in landfills and producing methane gas into the atmosphere. And then at the moment we're coming out ahead here, but land use, LUCF, is basically land clearing on the downside and reforestation and regrowth absorbing carbon on the positive side. So that's why actually that's helping us at the moment, because we're clearing less land than is regrowing, which is good, I guess. Now, the objective we really have is we really need to cut all these emissions as close to zero as fast as we can, because we have wasted 30 years. And that's a problem that we and our children and grandchildren have already locked in. So we really have to move fast. Now, just to talk a little bit about climate change, and of course everyone sees, yes, global warming. And so what's happening is that the distribution of temperatures is sort of shifting to get hotter on average. And this just shows the distribution. So we have a few, we have a few hot days, we have a few cold days, and a whole lot of days in the middle. So the average has already moved up by 1 degree. And in doing that, because of the shape of the distribution, the number of hot days has more than quadrupled in the last 60 years. Now, the problem we've got is if we move another degree, which we're struggling to limit warming to that, then we will move up to somewhere here, So we will double what is already a quadrupling of the warm days, the hot days, right? So this is a challenge for us. And so we are basically energising the climate. And that means we are going to have more extreme temperatures, higher winds, more humid nights, increased bushfire risk, both in frequency and intensity, and in more areas. We're going to have more inundation and beach erosion, all sorts of things like this. Basically, we're kind of confronting a lot of change, and we have to think about that when we're thinking about our homes as much as anything else. And also, a lot of people don't realise, but each degree warmer the air gets, it can hold 7% more water vapour. Now, anyone who's run a clothes dryer and seen you heat up the clothes, you get the water vapour, and then it all condenses on the windows and everything, right? So that's showing we heat the air so that it can remove the water from the clothes by evaporating it. Well, that's because air can hold a lot more water vapour when it's hotter. And that's what we're doing to the atmosphere. And that's where, if you go to the tropics, you have experienced heavier downfalls. Well, that's because there's more water vapour in the air. Also, we're stressing a lot of our infrastructure, in particular energy supply, so it's harder to manage the peaks and the troughs of change. There's also a lot of financial impacts on a lot of individuals and businesses, and this is a real challenge. You know, for example, if you're trying to recover from losing your house in a bushfire, that's a big financial impact. But we're also seeing things like blocks of land that people planned to build on may not be buildable anymore. So there's lots of issues, and there's also the psychological effects. I've got family in the Dandenongs, and you know, on a bushfire day, do you pack up the kids and come down to visit me in the city, or do you send them off to school and you go off to work? This uncertainty eats away at people, and we're going to have to learn to deal with that. And lots of businesses are discovering that, you know, growing all your bananas in one part of Australia is not a great idea if it gets hit by a cyclone. All these sorts of things are starting to happen. Okay, so now let's start looking a bit more locally, and this is from a thing called the Snapshot, which is a group who are trying to develop greenhouse footprints, climate footprints for every local government in Australia. And so what they're saying about the Colac-Otway region, and this is your whole shire, not just you, is that in fact over half of your emissions are related to agriculture. So this is cattle burping and fertiliser releasing gases and all sorts of stuff like that. Industry's fairly big too. Then we get to the commercial sector, the residential sector. Snapshot don't do transport, so I had a rough go at what your passenger transport might be. So these are all about equal with each other. Then there's a few other little bits. So that's the big picture for your region, and so your agriculture sector will be quite important. And there are lots of people doing great stuff in agriculture. So some parts of the agriculture sector are aiming to be carbon neutral by 2030. So, you know, it's not necessarily a problem, it is an opportunity. Looking at electricity, and this is all stolen from the SOS report, the breakdown of your local electricity is more than half of it is the commercial sector, and I think that reflects your tourism industry to a great extent. Then residential is the next biggest at about a third, and then you've got your industrial and agricultural. So, but again, touching a bit on what Matt was talking about, the average day, the electricity demand varies over time, right? So this is midnight, midday, and so on. And so typically what you see is things like at night, a lot of you have probably got off-peak electric hot water services, which are running at night. and they use surprising amounts of electricity. But also there'll be street lights and a whole bunch of things like that. Then in the early hours, everything shuts down because the hot water's heated up and all of that. Then we all get up and start doing things. The middle of the day now is starting to be a dip. It used to be the peak. And this is reflecting all of these people sticking solar panels on their roofs. It's just spoiling the day for the electricity industry. The coal guys don't like this because they don't like turning down their coal-fired power stations. It hurts them. And then, of course, afternoon, evening, you start getting more consumption. So that's the kind of typical day. This is actually the whole year for the power core substation at Colac, which feeds Apollo Bay. And again, Matt pointed out that some days you have quite astounding peaks. And I'm going to talk about those two ones that are stars at the moment. But what you can see is that on average, your consumption does go up a bit in winter. And again, it is interesting that you haven't got many people here then. So this is saying something about the heating and lights and stuff like that in your houses. But you can see, you know, each day the power consumption drops off in the early hours of the morning, and then depending on what kind of day it is, it goes up to a peak. So that's the kind of annual picture that's around. Now, I've chosen 2 days. The Friday of the Queen's birthday weekend, which is the grey one, appropriate for Victoria, clouds. And the red one is the 30th of December, which was the Christmas New Year period, and it was 42 degrees. And so again, once you start looking at what's happening, again, you do see, here's the off-peak electric water heaters and things like that. What we've got then on the really hot day is this really big daytime peak, it was really hot. Everyone was running cooling, you know, everyone was buying ice creams, you know, all that sort of stuff was happening. And I think what then happened, you might have actually had a cool change about 6 o'clock. Lucky you, because it could have gone even higher. And in the winter, again, we've got this afternoon, evening, and this is not just late at night when the off-peak hot water comes in. So this is likely to be people running resistive electric heating like fan heaters and radiators and things like that, which are not very efficient compared with the summer air conditioners, which are, you know, 3 or 4 times more efficient than an electric fan heater. So that's kind of one reason why you're using different appliances in winter from summer. So that's giving us some kind of perspective there. Now getting on to our individual homes, pretty much every home in Victoria has what is euphemistically called a smart meter. I call them a dumb smart meter because you can't get the data out of them immediately. You have to wait till the next day, which is a bit annoying really. But most of your energy retailers do have a website somewhere where you can actually see what your consumption was like on a day-by-day basis. So this is my place. So you can see here I went away on holidays and switched off the hot water service. The fridge and a couple of other things were running. You know, here it was obviously cold and I was home feeling the cold, so I was running lots of heating. So you can start to get a picture of what's going on in your home. And if you've got quite high consumption when no one's home, that's telling you that you've got an inefficient fridge or you're leaving lots of appliances and equipment running on what's called standby. So that can be an issue. Also, a lot of the retailers, this one, I'm with Power Shop, so they produce this, which actually looks at every half an hour on each day. And the brighter the colour, the more power you were using. So here's when my electric heat pump water heater runs normally, except when I go away on holidays. And then the day after I got back, that's when it heated up a whole tank of water, so it did use lots. But again, you can start to see what times of day was I using a lot of power. What was I doing at that time? You know, was I running my washing machine or ironing or cooking food or whatever? Oops, sorry. The other thing is that there are now increasing numbers of really good technologies. This is one that the Victorian government actually offers for free, except they don't offer it in all postcodes, and I've checked your postcode and it's not available for you at the moment. This could be a good thing for SOS to campaign on. But these little things clip on to your electricity meter, and they have an app on your mobile phone, and you can actually see real time, like the last few minutes, what's been going on. So you can actually do experiments and things, like you can switch on the TV for a while and see what difference it made. So you can actually, you know, boil the kettle or whatever. So you can kind of get a feel for what impacts different appliances that you have are causing. So the information is really important. Without knowing what's going on, it's very hard for us to choose the best things to do. Another source of information that's very important is the Appliance Energy Labelling Program, and quite a lot of appliances do now carry energy labels. And the energy label has two things. One is it has an efficiency rating, and the second thing is it has a consumption number. The efficiency rating is per place setting in your dishwasher, or per kilogram of capacity of your washing machine, or per litre of storage capacity of your fridge. So you can have a really big fridge and it can get lots of stars but still use quite a lot of energy in the number box. So the number box is telling you what it will do to your bill. The stars are telling you how efficient it is relative to other products of about the same size. There's a new label starting to appear for reverse cycle air conditioners, because reverse cycle air conditioners work differently in hotter and colder climates. And so they're now actually giving you a cooling efficiency, a heating efficiency for 3 different climate zones in Australia, so you can choose an appropriate product. Unfortunately, this is being phased in over 3 years, so not all the products have got this, which is a bit annoying, but there you are. This is very important because each extra star saves you about 15 to 25% on your running costs. So it's quite a big thing. The other thing that you have to keep in mind is that they've actually changed the scales a few times. So friends of mine have got a 1990s fridge which has got a 5-star rating, and they say, hey, it's pretty good. Unfortunately, we've changed the scale twice since then, and that's actually equivalent to 1.5 stars in today's star rating. So there's tricks of the trade here about what's going on. Now, lots of people are installing rooftop solar, and this is a great thing to do. Let me be clear, I'm not criticising it, but it's not a silver bullet. Because in winter, you get a lot less solar electricity than you do in summer. And in Melbourne, you can have pretty cloudy periods in summer when you don't get much electricity. So solar's great, but it's not a solution by itself. And this is where David's point about energy efficiency is very important, because if we use energy efficient products, we need a lot less electricity to deliver the same services. And we are generally more comfortable, and a lot of efficient appliances work better. So you want to be energy efficient. We are moving into a world of a whole lot of change. So we are starting to find that people are being asked to switch off their air conditioner at certain times, or the energy company might even do it for you if you agree and they pay you enough. We're introducing batteries and things to store energy for when we want it. And of course, an off-peak electric hot water service is an energy storage, right? You heat it up at night and you use the hot water when you want it, right? So that's where we're moving with a lot of other things. You're producing renewable energy on site. It's really important, even now, to look at what energy pricing contract you've got, because you can save a lot of money by choosing the right price, and there is a Victorian Government Energy Compare website that will allow you to compare the different options. And we're going to start trading energy and doing all sorts of weird things in the future. I'm not quite sure how it's going to work. But the thing is, and also you can buy carbon offsets, which your council is doing to move towards carbon neutral. So all these kinds of things are starting to happen. It's quite amazing what's going on, but also confusing if you're not on top of it all. Now, quickly into some home stuff, because I'm conscious I should finish pretty soon. This is for the whole of Victoria. So this is the mythical Victorian home with 2.4 people and half or 2/3 of a gas hot water service and 1/3 of an electric hot water service. You know, it's not everyone. But if we look at our electricity, what we see is electric appliances are the big thing. And of these electric appliances, our fridges are actually by far the biggest, plus our IT equipment and our TVs and internet and stuff like that are also pretty big. If you have a pool pump, that's only 6% of Victoria's electricity, but only 10% of Victorian households have pools. So if you've got a pool, it can be a really big consumer, and there's now an energy labelling program for pool pumps, which is very good. So that's electricity. If you look at metered energy, suddenly heating and cooling becomes the biggest thing. That's because most Victorian homes are using gas, not electricity, for heating. So this is where the gas heating is kicking in and being really big. If we look at summer peak electricity on a hot day, surprise, surprise, cooling is a big part of our electricity. If we look at our total bills, what we actually find is that a fair bit of a lot of Victorian households' energy bills is fixed charges. You know, you pay about $1, $1.20 a day to be connected to the electricity. You pay 80 cents or $1 a day to be connected to the gas pipes. That's a lot, especially if you're a small household or you're efficient. Fixed charges are a real problem. And some are lower than others, which is where you look at the contracts. And in terms of greenhouse emissions, again, we see electric appliances, heating and cooling, hot water, lights, cooking is the other one. They're the sorts of things we've got quite a bit of. Okay, now I'm going to have to skim really fast on the bits that possibly might be most interesting to you, but we can come back and talk about all this. So when we're thinking about a home, it's important to think about where we put it, because transport energy, as I showed you, is pretty big issue, and transport's pretty expensive for us. Owning cars and things like that costs a lot of money. What's the climate? What sources of energy have we got? The site that we have we got some solar access? Are we exposed to cold winds or hot winds? Are our neighbours or the trees around us affecting our access to sun and so on? Are we facing our building in a sensible direction? Are we putting it in a good spot on the site? Have we built a really efficient building? And have we got lots of efficient appliances and smart things in there? So these are the sorts of things we think about. I don't have time to go through this in much detail, but again, each orientation of a building has strengths and weaknesses, and it's important when you're thinking about where am I going to put the windows to think about these things. Also, it's important to realise that in summer the sun rises south of east, in winter it rises north of east. So if, say, you've got east windows, if you've got a bunch of trees here, they'll block out the morning sun in summer, but they'll still let the winter sun in. So east windows can work, especially if they're double glazed. North windows can be really good, but in winter the sun's pretty low in the sky. So if you've got a lot of trees out here, you may not get much winter sun. And in fact, your north windows might cook you in summer, unless they're well shaded. So these are the sorts of things to think about, and obviously Western orientation is often a challenge, but you can deal with it. And of course, South's cooler all the year. So that's the sorts of things to think about there. This slide just shows you for an uninsulated house, which in theory we don't have many of anymore, but in practice we do. So it's not surprising. A lot of the heat flows in through the roof or out through the roof, the walls and the floors. Insulation can fix all that. Windows can be big heat in or heat out issues, and air leakage is also big. So they're the sorts of things that we look at when we're trying to get a good building. I'm almost finished now. So all of our new homes have to get a 6-star energy rating. And so this blue graph line here shows the annual amount of energy per square metre of floor area for everything from a half a star up to 10 stars, which is the maximum, which is pretty much zero heating and cooling. So you can see 6 stars is an awful lot better than most of our older homes. They are much more efficient. They would be illegal in much of Europe and quite a few parts of the United States because a lot of them require 8 stars. So while 6 stars sounds good, it's not that good. This is my last slide. This is the other thing. We use a computer model to calculate your star rating, which actually models the performance and the heat flows into and out of your building every hour of the year. And it is possible with the right rating guys to actually extract information to look at each space in your house and see how comfortable or uncomfortable it is on a cold day and a hot day. So here we have a hot day where it hits 38 degrees, and you can see the 9-star house, which is the solid lines, is a lot cooler than the living and kitchen areas in the 6-star house. And of course, the 2-star house is kind of somewhere off this scale. Same in winter. Here it's really cold. The 9-star house is pretty comfortable all the time, but the other one varies a lot. So every house energy, every new house is rated, and you can get them rated for your existing house if you want, and that can help you understand what parts of your house are the problem, and you can play around with the tool to work out what things you should do best. So I'll finish there, and I'm probably a bit over time, but sorry. Okay, all right, well, and I'll be around for the rest of the evening, and we're going to have question and answer, and I'm very happy to chat with you about all these things. Okay, thank you. Okay.